Tonight, we're going to discover why humanity may never find its way home after leaving the solar system. Here on Earth, finding your way back is something you almost never think about. Your phone knows where you are. A compass points north. Maps tell you exactly which road to take. Home feels permanent, as if it's waiting exactly where you left it. But the universe doesn't work that way. Travel far enough into deep space and something extraordinary happens. Home stops being a place. It becomes a moving target in a universe where nothing, not your planet, not your sun, not even your galaxy, ever stands still. That sounds impossible. After all, Earth has always been right here, hasn't it? The truth is that while you've been listening to these words, our planet has already traveled thousands of kilometers through space. By the time this sentence ends, the Earth you were standing on no longer exists in the same location. It's gone, replaced by a new position that will never be occupied again. And that's where the real problem begins. Most people believe interstellar travel is simply about building faster rockets, bigger engines, better technology. We imagine that once humanity becomes advanced enough, crossing the distance between the stars will be inevitable. But what if we've been solving the wrong problem all along? What if reaching another star isn't the greatest challenge? What if finding your way back is? To understand why, we have to look at the greatest journey humanity has ever attempted. Nearly 50 years ago, NASA launched a spacecraft called Voyager 1. It has traveled farther than any human-made object in history, moving through space at incredible speed without stopping for almost half a century. If any machine has begun humanity's journey to the stars, it's Voyager. But Voyager didn't just reveal the size of the solar system. It revealed something far more unsettling. It showed us that the universe isn't simply unimaginably large. It's constantly moving. And once you truly understand what that means, you'll never think about the word home the same way again. To understand why home is a moving target, we have to confront a reality that our brains are simply not wired to perceive. Here on Earth, we feel stationary. We look at the ground beneath our feet and we see something solid, fixed, and eternal. But this is a grand, cosmic illusion. Even as you sit perfectly still, you're screaming through the universe at speeds that would terrify you if you could feel them. Our planet is rotating at 1,600 kilometers per hour. It is orbiting the sun at 30 kilometers every single second. And the sun itself is dragging our entire solar system around the center of the Milky Way at a staggering 800,000 kilometers per hour. This means that the location of Earth is not a fixed coordinate in space. It is a flickering moment in time. If you were to launch a starship today and travel for just 1 year, the point in space where you started, the place where Earth was when you said goodbye, is now billions of kilometers behind you. There is no physical marker left in that void. There is no trail of breadcrumbs. There is only the cold, empty space where a planet used to be. Most people imagine interstellar travel like a ship crossing an ocean toward a distant island. But the reality is more like a bullet fired from a moving train, trying to hit a target on another moving train, in a world where the tracks are constantly being rewritten by gravity. This is the lesson Voyager 1 began to teach us the moment it crossed the heliopause. We celebrated that milestone as leaving home. But Voyager didn't leave a place, it left a lifeline. Voyager moves at 17 kilometers per second, a speed so great it could cross the entire United States in 4 minutes. Yet in the 46 years since its launch, it has only traveled about 22 light hours away. To put that in perspective, the nearest star is over 4 light years away. If the distance to the nearest star were a marathon, Voyager has only taken its first 3 steps. And yet, even at this tiny, microscopic distance, the umbilical cord of navigation is already fraying. We stay in contact with Voyager through the Deep Space Network, a collection of massive radio telescopes scattered across the Earth. We send a signal, and we wait. Today, it takes nearly a full day for a command to reach Voyager, and another day for the confirmation to return. We are shouting into the dark, and the delay is growing. But the real terror isn't the delay, it's the realization that we are aiming at a ghost. By the time our signal reaches Voyager, the spacecraft is no longer where we thought it was. And by the time Voyager's reply reaches us, the Earth has moved millions of kilometers in its own orbital dance. We are two ghosts whispering to each other across an ever-widening graveyard of distance. Think about what this means for a human crew on a multi-generational voyage. We imagine them looking out the back window and seeing the pale blue dot growing smaller, but always remaining a fixed point of reference. But space is not a flat map. It is a three-dimensional abyss with no up and no down. As the ship moves deeper into the dark, the familiar constellations, the very landmarks humanity has used to navigate for thousands of years, begin to distort and shift. The stars you relied on to find your way are moving too, drifting in their own galactic orbits. After 50 years in the void, the sky you see through the cockpit would be a stranger to you. You wouldn't just be lost in distance, you would be lost in a sky that no longer recognizes you. This is where the psychological weight of the journey begins to crush the spirit. On Earth, going home is a physical act of retracing your steps. You turn around, you follow the road back, and the house is there. But in deep space, you cannot simply turn around. To go back to where Earth was is to find nothing but empty vacuum. To go back to where Earth is requires a calculation so complex that even a microscopic error in your initial heading would cause you to miss the entire solar system by millions of miles. You aren't just trying to find a planet. You are trying to intercept a moving grain of sand in a dark, infinite room while you yourself are blindfolded and moving in a different direction. We've built our entire philosophy of exploration on the idea of the return. The hero leaves, faces the unknown, and eventually walks back through the familiar gates of home. But interstellar space is the end of the return. It is a one-way door. The moment the engines fire and the ship accelerates toward the stars, the Earth begins to slip away, not just in distance, but in reality. The home you remember becomes a historical event, a coordinate in a past that no longer exists. If you were to look back after a century of travel, you wouldn't see a planet, you would see a void, and you would realize with a chilling certainty that you haven't just left your home behind. You have lost the very ability to define where it is. If Earth isn't standing still and the stars are shifting and the very light that reaches your eyes is years out of date, then what exactly are you trying to return to? The answer is a ghost, a memory. A target that has already moved on, leaving you alone in a universe that doesn't have a map. And as we look deeper into the mechanics of this cosmic dance, we begin to see that the problem isn't just our speed or our technology. It's the very structure of the universe itself. We are living in a house where the rooms are constantly changing places, and we've just stepped out the front door without realizing that the door is already gone. To understand how we truly become lost, we have to look at the scales of motion that govern everything we see. The invisible choreography of the galaxy that ensures that in the deep dark, no one ever really finds their way back. To understand why you can never find your way home, we must first confront the greatest illusion of the human experience, the illusion of stillness. As you sit here, perhaps in a room you've known for years, everything feels solid. The walls don't move. The floor beneath you is a constant. You feel like a stationary observer in a stable world. But the reality is that you are currently a passenger on a cosmic carousel that is spinning, orbiting, and drifting at speeds that would shatter your mind if you could actually perceive them. We are living in a universe where the very concept of a fixed point is a biological lie our brains tell us just so we can function. In this section, we are going to dismantle the map of the universe and realize that Earth is not a house sitting on a street. It is a ghost haunting 1,000 different positions every second, and it never occupies the same one twice. The first layer of this motion is the most familiar, yet it is already faster than any machine most of us will ever ride. At this very moment, depending on your latitude, you're spinning around the center of the Earth at up to 1,600 kilometers per hour. This is the rotation that gives us day and night, a gentle cycle we have mistaken for a stationary existence. But this is just the beginning of the dance. While we spin, we are also hurtling through the void in a nearly circular path around the sun. We call this an orbit, a word that sounds orderly and safe. But the reality is that Earth is a projectile traveling at 107,000 kilometers per hour. That is 30 kilometers every second. In the time it takes you to blink, the planet has moved further than the length of a dozen football fields. Most people believe that after a year, the Earth returns to the same spot in its orbit. We celebrate New Year S as a completion of a circle, but this is where the tragedy of navigation begins. The sun is not sitting still. The sun is a massive, burning star that is itself orbiting the center of the Milky Way galaxy. It is dragging the entire solar system along with it, Earth, Mars, Jupiter, and every moon and asteroid, at a staggering 828,000 kilometers per hour. This means that the path Earth traces through the universe is not a closed circle. It is a spiral. It is a long, winding corkscrew through the dark. When we celebrate a new year, we aren't returning to where we started. We are arriving at a point billions of kilometers away from where we were last January. We are travelers on a journey that has no return loop. Every lap we take around the sun is actually a step deeper into a part of the galaxy we have never seen before. But even the galaxy itself offers no stability. The Milky Way is part of a small collection of galaxies we call the local group, and the local group is currently drifting through the intergalactic void at over 2 million kilometers per hour. We are being pulled. There is a silent, invisible concentration of mass hidden behind the dust of our own galaxy, something astronomers call the Great Attractor. It is a gravitational anomaly so massive that it is dragging tens of thousands of galaxies, including our own, toward a destination we cannot fully see. We are not just moving, we are being harvested by a cosmic force that operates on a scale that makes our entire history look like a microscopic event. And then there is the final, most absolute motion of all, the expansion of space itself. This is perhaps the hardest concept for the human mind to grasp. It isn't just that things are moving through space, it is that the fabric of space between the galaxies is stretching. Imagine a balloon being inflated. If you draw two dots on that balloon, they move away from each other not because they are walking, but because the floor beneath them is growing. This is the ultimate engine of isolation. The universe is stretching, pulling the galaxies apart, ensuring that as time goes on, the distances between us and the rest of the cosmos only grow larger. The floor of the universe is expanding, and there is no way to walk back to where you were because the path itself has changed its size. What does this mean for the Starship Navigator? It means that every map humanity has ever produced is a lie. A map is built on the assumption that you can mark a where. But in a universe of nested motions, there is no where, there is only when. If you launch a starship toward Alpha Centauri and you decide to turn around after 10 years, you are not looking for a planet, you are looking for a memory. You have to calculate where the Earth will be after its rotation, its orbit, the sun's galactic drift, the Milky Way's movement toward the Great Attractor, and the expansion of the space in between. You are trying to hit a moving target that is moving in 6 different directions at once, across a distance that is itself stretching. Think about the precision required. If your calculations are off by even a fraction of a percent, if you don't perfectly account for the sun's velocity or the subtle tug of a distant galaxy, you won't just arrive late, you will arrive in empty space. You will find yourself at the exact coordinates where Earth should have been, only to realize that the planet has already swept past that point hours ago, leaving nothing behind but the cold radiation of its ghost. You are a hunter trying to hit a bird in a hurricane from 1,000 miles away while standing on a moving train. This is the realization that breaks the spirit of the deep space traveler. On Earth, we have the luxury of stillness. We have landmarks, we have a North Star, we have a ground that stays put, but interstellar space is the end of stillness. It is the realization that we are living on a grain of sand that is being blown through a cosmic sandstorm. There is no stationary Earth waiting for you to find it. There is only a trajectory. There is only a path that never crosses itself. If you leave, you aren't just leaving a place. You are leaving a moment in time that the universe will never recreate. Every map we've ever made is already outdated the moment the ink dries, because the world it describes has already moved on. As we move further away from the sun, we begin to realize that the problem isn't just that everything is moving. The problem is that the tools we use to measure that motion, the very things we rely on to tell us which way is up or back, begin to fail the moment we leave the neighborhood. We are about to enter a realm where the compass doesn't point north, the stars begin to lie, and the very concept of a direction starts to dissolve. If Earth is a moving target, and we are moving too, then how do we even begin to draw a line back home? The answer is that we can't, because the deeper you go, the more you realize that space has no floor, no ceiling, and no memory of where you came from. And this leads us to a terrifying question. If nothing in the universe is standing still, then how do we know we're even moving in the right direction? To find out, we have to look at the next wall of navigation, the reason why all our methods for finding our way only work as long as we can still hear the whispers of home. Tonight, we take for granted the invisible web of technology that surrounds us. We move through our cities and across our oceans with a level of confidence that would have seemed godlike to our ancestors. If you want to find a hidden trail in the mountains or a specific street in a foreign city, you simply reach into your pocket and consult a glowing screen. We have wrapped our planet in a layer of silicon and radio waves, creating a world where getting lost is almost a choice. But what if I told you that the very devices that guide you to your local grocery store are the same ones that will betray you the moment you leave the sun's shadow? What if the tools we've spent billions of dollars perfecting are not universal keys to the cosmos, but local toys that only work because we are still within sight of home? In this section, we are going to explore the death of navigation, the terrifying moment when our most advanced systems fall silent, and we realize that we are trying to navigate a forest using tools built only for the backyard. To understand why our systems fail, we have to look at the first and oldest tool of the traveler, the compass. For 1,000 years, the compass has been the symbol of direction. It works because Earth is essentially a massive, rotating magnet. Our planet's molten core generates a magnetic field that stretches out into space, creating a north and a south that a simple magnetized needle can always find. But the moment a starship leaves the Earth's magnetosphere, the compass becomes a piece of junk. As you move toward the edge of the solar system, the Earth's magnetic pull weakens until it is drowned out by the sun's own magnetic field. And if you go further, past the heliopause and into the interstellar void, even the sun's influence vanishes. In deep space, north does not exist. There is no magnetic floor. There is no planetary heart beating a signal of direction. A compass in deep space wouldn't point you home. It would spin aimlessly, a haunting reminder that you are in a place where the very concept of up and down has been erased. We tell ourselves that we've moved past the compass. We have GPS. We have a network of 31 satellites orbiting 20,000 kilometers above our heads, ticking with the precision of atomic clocks. GPS is the ultimate umbilical cord of modern life. It works through a process called triliteration, measuring the tiny, microscopic differences in the time it takes for a signal to travel from a satellite to your phone. But GPS is a local phenomenon. It is a bubble. The moment you move past the moon, the geometry of GPS collapses. The signals meant to point down toward Earth become faint whispers lost in the background noise of the sun. To a starship in the interstellar dark, GPS is not a tool. It is a ghost of a civilization that was too small to think beyond its own orbit. We are trying to navigate the Pacific Ocean using the instructions for a garden maze. But surely we have something better. We have the Deep Space Network, the DSN. This is humanity's real connection to the stars. It is a collection of massive 70-meter radio dishes in California, Spain, and Australia, designed to track our furthest probes. This is how we talk to Voyager 1. This is how we know its speed, its trajectory, and its distance. But the DSN is not a navigation system for the ship. It is a tracking system for the Earth. It depends entirely on the round trip. We send a signal at the speed of light, it hits the spacecraft, and it bounces back. By measuring that delay, we can calculate distance with incredible precision. But here is the retention wall of deep space physics. The speed of light is too slow for the scale of the universe. Imagine you are on a starship 5 light-years away. You encounter a gravitational anomaly, or you realize your course is drifting. You send a distress signal to Earth. That signal travels at 300,000 kilometers per second, yet it will take over 4 years to reach the DSN dishes. The engineers on Earth receive your message, calculate a correction, and send it back. Another 4 years pass. By the time the solution reaches your ship, 8 years have gone by. You are no longer in the same position. The problem you reported is ancient history. You might already be dead. This is the death of real-time support. In deep space, you are not being guided by Earth. You are being sent a series of postcards from a past that no longer exists. The farther you go, the more the DSN becomes a psychological comfort rather than a navigational tool. It is a fading echo of a mother's voice, and eventually, the echo becomes so faint that the silence of the void swallows it whole. So if radio contact and GPS fail, we rely on the stars. This is called stellar navigation, and it is what our current probes use. They carry star trackers, sophisticated cameras that take photos of the sky and compare them to an internal map. It's like a digital version of what ancient sailors did. If the camera sees Orion and the Big Dipper in a certain configuration, it knows where it is. But this method only works because we are currently near home. On the scale of the galaxy, all the stars we see in the night sky are our immediate neighbors. They look fixed because we are moving with them. But as you push into the deep dark, the parallax trap begins to set in. Parallax is the apparent shift of an object when viewed from different positions. Hold your thumb out and close one eye, then the other. Your thumb seems to jump. This is how we measure distance to the stars. But the deeper you go into space, the smaller the jump becomes. Eventually, the jump disappears. The stars become a flat, two-dimensional wallpaper. Without the perspective provided by the Earth's wide orbit around the Sun, your star trackers lose their depth perception. You are a blind man trying to judge the distance of a mountain by looking at a photograph of it. The stars also begin to lie to you. This is a concept that breaks the mind of many who dream of space travel. We see the constellations as eternal shapes, the hunter, the lion, the bear, but those shapes only exist from the perspective of Earth. As you travel light years away, the stars that make up those constellations move relative to one another. Some are closer to you, some are further away. After a century of travel, Orion would be unrecognizable. The Big Dipper would be a chaotic smear of light. You are navigating through a forest where the trees are constantly changing their positions. The map you brought from Earth is not just old. It is a map of a reality that only exists back home. And then there is the problem of velocity distortion. If your ship is moving fast enough, say 10 or 20% of the speed of light, the light from the stars ahead of you begins to blue shift. They change color. They become more energetic, more violent. The stars behind you red shift, fading into dim infrared ghosts. The sky you see through the cockpit window is not the sky you saw from your backyard. It is a warped, psychedelic tunnel of light where the very colors of the universe are being distorted by your own speed. Your sensors, designed to recognize the specific signature of a star, would find themselves looking at strangers. What we are witnessing is the total collapse of the human reference frame. On Earth, we have a floor. In the solar system, we have the sun. But in the interstellar void, the floor is gone, and the sun is just another flickering candle in the dark. We are realizing that our technology is provincial. It was built for a world with a magnetic field, a world with a nearby star, and a world where the speed of light felt instantaneous. The deeper we go, the more these tools turn into liabilities. You aren't just losing your way, you are losing the very language of direction. This leads us to a terrifying conclusion. If our compasses spin, our GPS is dead, the DSN is too slow, and the stars themselves are changing their faces, then what exactly is left to guide us? We are entering a realm where direction is no longer a fact, but a guess. And as we move into the absolute emptiness between the stars, we have to face the next wall, a place where there is no up, no down, and no north. A place where the very concept of a straight line might be the greatest illusion of all. But even if you accept that there is no compass, surely you can just keep track of your own movements. Surely you can just count your steps. In the next section, we're going to discover why counting your steps in a universe that is constantly moving is a recipe for a quiet, permanent disappearance into the dark. Because in space, even the act of moving forward is a lie told by your own momentum. Imagine for a moment that you are the last person awake on a starship, drifting somewhere between the Sun and Alpha Centauri. You stand in the center of a darkened observation deck, looking out into the absolute blackness of the interstellar medium. You decide for just a moment to close your eyes. You try to sense where you are. You try to feel the direction of your movement. On Earth, even with your eyes closed, you have a sense of orientation. You feel the pull of gravity in your inner ear, telling you which way is down. You feel the weight of your body against the floor. You have a biological compass that ties you to the planet. But in the deep dark, that sense is gone. When you close your eyes in the void, there is no up, there is no down, there is no left or right. There is only a terrifying, hollow stillness. You are a mind floating in an abyss that has no walls, no floor, and no ceiling. And this is the beginning of the fourth wall of navigation. The realization that space does not have a compass, not because our tools are broken, but because the universe itself has no built-in sense of direction. To understand why this is a nightmare, we have to look at the very foundation of human movement. Since the first moment we stood upright, our brains have been evolved to navigate a three-dimensional world that is anchored by a two-dimensional floor. We think in terms of north, south, east, and west. These are not just words, they are the fundamental coordinates of our reality. They are based on the Earth's rotation and its magnetic poles. But once you move far enough into the deep space, north ceases to exist. There is no magnetic north in the interstellar void. There is no horizon to divide the sky from the ground. Space is a Cartesian nightmare, a three-dimensional grid where every direction is identical to every other. You could be traveling at 20% of the speed of light, but if you don't have a nearby planet or star to look at, you would feel as though you were standing perfectly still. You are moving through a vacuum that has no landmarks, no milestones, and no signs to tell you if you have drifted off course. This leads us to the heart of the problem, Einstein's revelation of the absolute frame. Before the 20th century, we believed that space was a fixed background, a giant, invisible stage on which the stars and planets performed their dance. We thought that if you could somehow step outside the universe, you would see a giant map with a zero coordinate in the center. But Einstein proved that this stage doesn't exist. There is no absolute frame of reference in the universe. There is no such thing as standing still in any absolute sense. You are only moving relative to something else. If you are in a ship with no windows, and you aren't accelerating, there is no experiment in physics that can tell you how fast you are going or which way you are headed. You are in a state of total relational isolation. Think about the psychological toll of this disorientation. On Earth, we have the luxury of directional certainty. If you get lost in a forest, you can at least tell which way is up. You can see the moss on the trees or the position of the sun. But in space, direction is an illusion. You are navigating a house where the rooms are not only moving, but where the hallway itself is a hallucination. We assume that if we could just turn around and point the ship back toward the sun, we would be fine. But what does turning around even mean when you don't have a fixed point to turn against? You are like a man floating in a pitch-black sensory deprivation tank, trying to figure out which way is north, when the water is the same temperature as your skin, and there isn't a single ray of light to guide you. In this environment, your brain begins to fabricate its own reality. You start to see up where there is only blackness, and you start to feel down where there is only vacuum. You are fighting against a universe that is systematically erasing your ability to orient yourself. But here is the unexpected twist, the moment where the science of the void becomes truly malicious. We imagine that space is a flat, empty room where a straight line is always a straight line. We think that if we just point the ship in one direction and keep going, we will eventually hit our target. But gravity is a master of deception. Einstein's general relativity tells us that mass, stars, planets, black holes, does not just pull on objects, it warps the very fabric of spacetime itself. The straight line you think you are traveling is actually curved. You are like an ant crawling across a wrinkled blanket. To the ant, it feels like it's going straight, but to an observer from above, the ant is spiraling, dipping into valleys and climbing over hills of invisible gravity. In deep space, you could be drifting off course by millions of miles, and you would never feel a thing. There is no bump when you hit a gravitational curve. There is no tilt when the ship begins to spiral. You are trapped in a smooth, silent slide toward a destination you didn't choose. By the time your instruments detect that your straight line has become a circle, it might be too late to correct. You are a passenger on a ghost train that is following invisible tracks laid down by stars that died billions of years ago. The very concept of a path is a lie told by a universe that is constantly bending the rules behind your back. This is the moment where the assumption of back is finally destroyed. On Earth, back is the opposite of forward. It is a 180-degree turn. But in a universe of warping spacetime and nested motions, back is a meaningless word. To return home, you can't just flip the ship and fire the engines. You have to retrace a path that has already been bent by the gravity of every star you passed. You have to account for the fact that the space you traveled through 5 years ago has already stretched and moved. You are trying to unknit a sweater while the yarn is constantly changing its own shape. We tell ourselves that we are explorers, but to explore, you must be able to return and tell the story. Interstellar space is the end of the explorer's return. It is a place where you are not just lost in distance, but lost in the very logic of direction. You are a speck of dust in a hurricane of invisible curves, trying to find your way back to a home that was never at a fixed coordinate to begin with. The void doesn't just keep you apart. It takes away your ability to even know which way apart is. You are standing in the center of the dark, looking at a sky that has no compass, realizing that the only thing more terrifying than being lost is the fact that found was never an option. But surely there is a way to cheat the system. Surely if we just count our steps with perfect precision, if we keep an unbroken record of every thruster fire and every microscopic nudge, we can calculate our way back. We call this dead reckoning, the oldest trick in the sailor's book. But as we are about to discover in the next section, counting your steps in the deep dark is a recipe for a very specific, very quiet kind of madness. Because in space, the biggest errors are the ones you don't even know you're making. And by the time you realize you've miscounted, the street you were looking for has already vanished into the past. What happens when a rounding error of a single millimeter becomes a gap of 1 billion miles? And how do we keep our sanity when we realize that the machine we trust to count our steps is slowly, quietly, losing its own sense of rhythm? The next wall of navigation is not a physical barrier. It is a mathematical trap, and once you fall into it, there is no way out. Imagine you are a blindfolded man standing in the middle of a vast, silent desert. You know that if you take exactly 1,000 steps in a perfectly straight line, you will reach a well with water. You have no compass, no landmarks, and no sun to guide you. All you have is your internal sense of rhythm and your ability to count. You take your first step, then your second. You are careful, incredibly careful. You try to keep your feet straight, your shoulders level, and your pace even. But with every step, there is a microscopic wobble in your ankle, a tiny invisible shift in the sand beneath your heel, a slight lean in your posture that you can't even feel. By step 500, you are still convinced you are walking a straight line. Your brain tells you that you are on track, but in reality, you have already veered off by a fraction of a degree. By step 1000, you aren't at the well. You are kilometers away in the scorching heat, walking toward a horizon that offers nothing but death. This is the nightmare of dead reckoning. It is the oldest and most intuitive form of navigation, but in the deep dark of interstellar space, it is a mathematical trap that turns the very act of counting into a slow, quiet suicide. To understand why dead reckoning fails so spectacularly in deep space, we have to look at how we've navigated the most isolated places on Earth. Long before GPS, sailors, pilots, and submariners relied on inertial navigation. They used gyroscopes and accelerometers, mechanical and electronic sensors that detect every turn, every acceleration, and every dip. If you know exactly where you started, and you record every single movement you've made since then, you should, in theory, always know where you are. We call this the black box approach. You don't need to look at the stars, you just need to trust the box. This is how a nuclear submarine stays hidden beneath the Arctic ice for months, navigating in absolute darkness. This is how the Apollo astronauts stayed on course during their 3-day journey to the moon. But every submariner and every Apollo engineer knows the terrifying secret of the black box: gyroscopes drift. In the world of engineering, there is no such thing as a perfect measurement. Every sensor has a noise floor. Every accelerometer has a tiny, microscopic bias. Every gyroscope has a drift rate, a slow, persistent error where the sensor believes it is rotating when it is perfectly still. On a submarine, this drift might be a few meters per hour. After a day, the sub might be off by 100 meters. It's manageable. The sub eventually surfaces, catches a GPS signal or a star fix, and resets its position. It clears the clock, but in interstellar space, there is no surfacing. There is no GPS reset. You are on a journey that lasts 50, 70, or 100 years. And in that time, the inertial drift doesn't just add up, it compounds. It is a digital cancer that eats away at the accuracy of your position until the map in your computer bears no resemblance to the reality outside your hull. Think about the math of the void. If your starship's navigation system has an error rate of just 0.0001%, a level of precision that would be considered a miracle on Earth, it seems harmless. Over the distance of a few kilometers, it's a few millimeters. Over the distance to the moon, it's a few hundred meters. But interstellar space is not measured in kilometers. It is measured in trillions of miles. Over a 4-light-year journey to Alpha Centauri, that 0.0001% error translates into a gap of millions of miles. By the time you expect to see the red glow of Proxima Centauri, you will find yourself in the absolute blackness of empty space, having missed the entire star system because of a rounding error in a computer chip that happened 40 years ago. You didn't slowly get lost. You were lost from the moment you took your first step, but the universe waited decades to show you the bill. This is the butterfly effect of deep space navigation. In a world of such staggering distances, the smallest cause leads to the most catastrophic effect. A microscopic wobble in a thruster fire in year 10 becomes a million-mile deviation in year 50. A thermal expansion in a gyroscope's housing during a power fluctuation in year 20 becomes a navigational blind spot that sends the ship spiraling into the dark. We have spent centuries building machines that are good enough for Earth, but the interstellar void demands a level of perfection that may be physically impossible. We are trying to balance a needle on its tip during a hurricane, and we are asking a machine to do it for a century without a single mistake. But surely our computers are better than that. We trust our digital systems with our lives every day. We assume that a computer doesn't drift like a mechanical gear. But this is the next assumption that space travel destroys. Computers operate on floating point math. They have to round numbers. They have to decide where pi ends. When you are calculating a trajectory across 40 trillion kilometers, those rounding errors are not just academic, they are physical. Every time the navigation computer updates its position, it loses a tiny microscopic bit of the truth. Over millions of updates across a century, the truth evaporates. The ship's brain becomes a hall of mirrors, where it is calculating a position based on a previous position that was already slightly wrong. The ship begins to hallucinate its own journey. It builds a beautiful, logical path back to Earth in its memory, while in reality, the ship is drifting further and further into a graveyard of stars. This is the psychological horror of dead reckoning for a starship crew. You spend your life looking at a screen that tells you exactly where you are. The numbers are precise. The graphics are clear. The ship's AI speaks with a calm, authoritative voice, assuring you that you are on course, that the sun is exactly where it should be, and that home is waiting for you at the end of the line. But deep down in the silent hours of the night, you realize that you have no way to verify those numbers. You are trapped in a feedback loop of trust. You are trusting a machine that is trusting its own history, and neither of you has seen a landmark in 40 years. You don't suddenly get lost in space. You suddenly discover that you have always been lost. You realize that the straight line you've been following was a curve, and the home you've been dreaming of is a target you missed decades ago. The Apollo 13 mission gave us a brief, terrifying glimpse of this reality. When their navigation computer was powered down to save energy, the astronauts were forced to navigate by the stars manually. They had to use the Earth's terminator line, the shadow between day and night, as a reference point. They were close enough to home to see the target. They could use their eyes to correct the drift of their failing machines. But an interstellar crew has no terminator line. They have no blue marble in the window. They have only the stars, and this is where the final betrayal occurs. We tell ourselves that even if our internal sensors fail, the stars will always be there. We think of them as the ultimate fixed points, the ancient lighthouses of the universe that never move. We assume that if we can just look out the window and see Orion or the Southern Cross, we can find our way back. But as we are about to discover in the next section, the stars are not lighthouses. They are not fixed. They are not your friends. In the deep dark, the very constellations you trust are moving in their own silent, chaotic orbits. The sky you use to check your math is itself a moving target. If you try to correct your drift by looking at the stars, you might find that the stars themselves are leading you into a trap from which there is no return. Even the sky, it turns out, has no memory of where you came from. For thousands of years, humanity has looked to the heavens and seen a map of absolute stability. To the ancient Greeks, the Polynesians, and the early European explorers, the stars were the fixed firmament, a silent, unblinking backdrop that never changed, never failed, and never lied. We built our civilizations, our religions, and our entire science of navigation on the assumption that if you know where the stars are, you know where you are. Even today, our most advanced interstellar probes, like Voyager and New Horizons, rely on star trackers, cameras that scan the sky and recognize the familiar patterns of the constellations to keep the ship on course. We believe deep in our cultural DNA that the sky is the ultimate lighthouse. But as we push out into the true deep dark, we are forced to confront a terrifying reality. The stars are not fixed, they are not lighthouses, and they are not your friends. In the interstellar void, the very constellations you trust to guide you home are part of a slow, chaotic dance that will eventually distort the sky beyond recognition. This is the betrayal of the stars, the moment you realize that the map of the universe is being rewritten every second you are in transit. To understand why the stars betray us, we first have to understand the illusion of the fixed sky. From our perspective on Earth, stars look stationary because of the staggering distances involved. They are so far away that their true movement across the galaxy is almost impossible to detect within a single human lifetime. But every star in the sky is moving. They are traveling in different directions, at different speeds, orbiting the center of the Milky Way in a complex, three-dimensional choreography. Astronomers call this proper motion. It is the slow, quiet drift of the stars across the heavens. On Earth, it takes tens of thousands of years for a constellation like the Big Dipper or Orion to noticeably change its shape. But a starship is not an Earth-bound observer. A starship is a traveler, moving through the very heart of that motion. Imagine you are 50 years into a voyage toward a distant sun. You look out the observation port, expecting to see the familiar W of Cassiopeia or the belt of Orion. But the shapes are wrong. The stars that made up those patterns, stars that were actually at vastly different distances from Earth, have shifted. Some have moved closer to you, some have drifted further away. Proper motion, combined with your own change in perspective, has begun to warp the sky. Orion's belt is no longer a straight line, it is a jagged, broken triangle. The Big Dipper has stretched into a meaningless smear of light. You are like a man who memorized the shape of a cloud, only to realize that as he walked toward it, the cloud was constantly changing its form. The stars you relied on to find your way are strangers now. They are no longer landmarks. They are just points of light in a sky that has no memory of the Earth you left behind. But the shift in position is only the beginning of the betrayal. As you travel faster, reaching 5, 10, or 20% of the speed of light, a much more violent phenomenon takes hold: stellar aberration. To understand aberration, imagine you are standing in a rainstorm. If you stand perfectly still, the rain falls straight down on your head. But if you start running, the rain appears to hit you at an angle, as if it's coming from in front of you. The faster you run, the steeper the angle becomes. The same thing happens with light. As your ship accelerates to relativistic speeds, the light from the stars begins to bunch up in the direction of your movement. Stars that should be to your side suddenly appear to be ahead of you. The entire sky begins to warp and fold toward the center of your cockpit window. You are looking at a sky that is physically distorted by your own velocity. Your navigation charts say a star should be at one coordinate, but your eyes and your sensors see it at another. You are trying to navigate a world that is being bent by your own movement, a hall of mirrors where forward and side are no longer fixed directions, but variables of your speed. This distortion is compounded by the color betrayal, the Doppler shift. We recognize stars not just by their position, but by their light. We know that certain stars are blue giants, others are yellow suns like our own, and others are dim red dwarfs. Our navigation computers use these spectral signatures to identify the stars and confirm our position. But as you race through the void, the very colors of the universe begin to lie to you. The stars ahead of your ship undergo blue shift. Their light is compressed, turning them into brilliant, violent shades of violet and blue. The stars behind you undergo red shift, their light stretching out until they fade into dim infrared ghosts. You are flying through a psychedelic tunnel where the stars you knew as yellow suns have become blue monsters, and the red stars of your home have vanished into the dark. Your instruments, designed to recognize the fingerprints of starlight, find themselves looking at a sky full of strangers. The universe hasn't changed, but your perception of it has been shattered by the very speed you needed to survive. Think about the psychological impact of the deforming sky. For every human in history, the stars have been a symbol of eternity. They are the only things that don't change. But for the interstellar traveler, the stars are the ultimate symbol of instability. You look out the window and you see a sky that is literally melting and warping around you. You lose the one thing that every sailor in history had, a fixed reference point. You are in a sensory deprivation tank, where the only things you can see are lying to you about where they are and what color they should be. You begin to feel a profound sense of directional vertigo. You are a mind floating in a warped reality, trying to use a 21st century star chart to navigate a 22nd century sky that has been bent by Einstein's laws. The deeper problem, however, is not just your perception, it is the data gap. Our star charts are built on observations made from a tiny, specific point in space, the solar system. We have measured the distances and motions of the stars with incredible precision, but that precision has a shelf life. Over decades of interstellar travel, the error bars in our stellar catalog begin to grow. A star's proper motion was measured as x, but over 50 years, a tiny miscalculation in its velocity leads to a gap of millions of miles. By the time you need that star to calculate your turnaround point, the star is no longer where the math says it should be. You are navigating with a map that is slowly, quietly becoming obsolete. The stars are drifting away from the coordinates we assigned them, reclaiming their own chaotic freedom. And then there is the parallax betrayal. On Earth, we use parallax, the apparent shift of a star against the background as we move around the sun to measure distance. It is our cosmic yardstick. But as you leave the solar system, the baseline of Earth's orbit vanishes. You are no longer moving in a circle around a sun. You are moving in a straight line through the void. Your depth perception begins to fail. Stars that look like they were in a specific 3D arrangement suddenly reveal themselves to be at vastly different depths. The constellations weren't real structures, they were just coincidences of perspective. As you move, those coincidences dissolve. You realize that the hunter or the lion was just a trick of the light, a pattern your ancestors made up to feel less alone in the dark. Now the pattern is gone, and you are left with the raw, disorganized reality of a galaxy that doesn't care about your shapes. This is the moment where the assumption of fixed navigation is finally destroyed. You realize that you cannot trust your eyes, you cannot trust your charts, and you cannot trust the very light that reaches your ship. You are navigating a house where the walls are moving, the lights are changing color, and the floor is bending under your feet. The stars have not just moved, they have betrayed the very idea of a landmark. You are truly alone in a universe that offers no fixed points to hold on to. We tell ourselves that we are starfarers, but we are actually sun-dwellers. Our entire understanding of direction is built on the stability of our own little corner of the galaxy. The moment we leave it, we discover that the universe is a place of restless, relentless motion. The stars are not lighthouses, they are projectiles just like you, screaming through the dark on their own secret trajectories. You are trying to find your way home using a sky that is actively trying to hide the path. But as the stars begin to lie and the sky begins to warp, you tell yourself that there is still one final lifeline. You tell yourself that even if you can't see the way back, you can still hear it. You have the radio. You have the massive dishes of the deep space network on Earth, sending out a steady, rhythmic pulse of information. You think that as long as you can hear the ping of home, you can never truly be lost. But as we are about to discover in the next section, even the voice of Earth is a lie. The radio signals you trust are not coming from where you think they are, and by the time they reach you, the world that sent them is already ancient history. The umbilical cord is not a connection. It is a time-lagged echo of a world that has already moved on without you. What happens when the only voice you have to guide you is a ghost from the past? Live in an age of instant echoes. On Earth, we have conquered the tyranny of distance through the speed of light. When you send a text, make a call, or stream a video, the information travels across the planet so fast that it feels as though time itself has been suspended. We have built our entire civilization on the assumption that communication is immediate, that we can reach out and touch anyone anywhere at any moment. This instant connection is the invisible fabric that holds our world together. It is the safety net that ensures that no matter how far we wander, the collective intelligence of humanity is only a fraction of a second away. But as a starship pushes out into the true deep dark, this fabric begins to tear. The safety net doesn't just fray, it dissolves entirely. In the interstellar void, the speed of light, the very thing that makes our world feel small, becomes a wall that makes the universe feel impossibly, terrifyingly large. This is the death of communication. The moment you realize that the radio signals you trust to guide you home are not a conversation, but a series of haunting echoes from a world that has already moved on without you. To understand why radio becomes useless, we have to confront the most fundamental speed limit in the universe, 300,000 kilometers per second. To our human brains, this seems infinite. It is fast enough to circle the Earth 7 times in a single heartbeat, but at the scale of the cosmos, the speed of light is a crawl. It is a slow, agonizing trickle of information. We see this reality today with the Deep Space Network, humanity's only ear in the dark. The DSN is a collection of massive 70-meter radio dishes scattered across Goldstone, California, Madrid, Spain, and Canberra, Australia. These dishes are the most sensitive instruments we have ever built, capable of catching a signal from Voyager 1 that is so faint it carries less energy than a billionth of a watt. But even with these godlike ears, the physics of the void is merciless. Voyager 1 is currently about 24 billion kilometers away. When Mission Control sends a command to Voyager, perhaps a simple instruction to switch to a backup thruster, the signal takes over 22 hours to reach the spacecraft. If Voyager sends a reply immediately, it takes another 22 hours to return. Every conversation with Voyager 1 has a 44-hour delay. We are shouting into the dark, and we have to wait nearly 2 full days just to hear the echo. This is the reality of our most distant machine, which is still, on a cosmic scale, in our own backyard. Now imagine a starship at the edge of our neighboring star system, Proxima Centauri, 4 light-years away. If that ship encounters a critical engine failure and sends a plea for help, the message will take over 4 years to reach Earth. If the engineers at NASA solve the problem instantly and broadcast the solution, it takes another 4 years to get back. By the time the ship receives the answer, 8 years have passed. The crew that sent the message is either long dead or has drifted millions of miles off course, and the version of Earth they are talking to has moved through an entire decade of history. This is the lag of reality. In deep space, you are never communicating with the present. You are always communicating with the past. Every signal you receive from Mission Control is a voice from a world that no longer exists in that state. You are being guided by the memories of people who may have retired, died, or forgotten the specifics of your mission by the time your reply reaches them. The umbilical cord of information is no longer a lifeline, it is a ghost. The psychological toll of this communication gap is a slow-motion isolation that no human has ever truly experienced. On Earth, even in the most remote corners of the wilderness, you can feel the pulse of the world through a satellite phone. But in the deep dark, you are truly, profoundly alone. You are a mind trapped in a metal tube, shouting at a planet that is too far away to hear you in time to matter. But the problem isn't just the time, it's the aiming of the signal. As we discussed in earlier sections, nothing in the universe holds still. Earth is rotating, orbiting the sun and hurtling through the galaxy. Voyager 1 is moving in a different direction. To maintain contact, the Deep Space Network has to aim its massive dishes at a specific point in the sky. But because of the light delay, they aren't aiming at where Voyager is. They are aiming at where Voyager was 22 hours ago. And Voyager is aiming its high-gain antenna at where Earth was a day ago. It is a delicate, invisible dance of ghosts. As the distances grow from light hours to light years, the aperture of contact becomes incredibly narrow. If the ship's navigation computer drifts by even a fraction of a degree, or if the DSN loses its lock for even a few minutes, the signal is lost. And in the silence that follows, there is no redial button. You are trying to find a needle in a haystack, except the needle is a billion miles away, and both you and the haystack are moving at tens of thousands of kilometers per hour. This creates a terrifying information decoupling. On Earth, we rely on Mission Control to be our external brain. They run the simulations, they monitor the telemetry, and they make the hard decisions. But in deep space, the ship must become its own Earth. It must have the processing power, the expertise, and the authority to make every life or death decision in real time, because help is years away. The crew is no longer a group of explorers. They are a fragment of humanity that has been surgically removed from the collective. They are a brain that has been severed from its body. This isolation isn't just a technical challenge, it is an existential crisis. If the ship's library doesn't contain the answer to a problem, and the crew cannot figure it out, they will die in the dark before Earth even knows they were in trouble. We must also face the reality of atmospheric and galactic noise. The deeper you go, the more your signal has to compete with the screaming of the universe. The sun, the stars, the nebulas, and the cosmic microwave background are all pouring out radio energy. Your ship's signal is a candle flame in a hurricane of electromagnetic noise. To catch that flame, the DSN must filter out the entire galaxy. As the ship moves further away, the signal-to-noise ratio drops until the voice of Earth becomes indistinguishable from the background hiss of the Big Bang. The umbilical cord doesn't just stretch, it fades into the static. You reach a point where you can no longer hear the heartbeat of home, not because the heart has stopped, but because the distance has turned it into a whisper that the universe has simply swallowed. This leads to the final silence, the moment the crew realizes that they are the only people in existence who know they are alive. They look at the monitors and the signal lock light goes out. They realize that the Earth, for all its beauty and its billions of people, is now just a concept. It is no longer a participant in their journey. They are an island of life in a sea of absolute, uncaring silence. The radio, which once brought news of family, music, and the politics of a blue world, now offers nothing but the crackle of distant stars. You aren't just lost in space, you are lost in a silent era of your own making. But as the radio fails and the voice of Earth vanishes into the static, a new and stranger possibility emerges. If we cannot rely on the voices of humans to find our way, perhaps we can rely on the voices of the stars themselves. If the DSN is too slow and the sun is too dim, we must look for a different kind of lighthouse, one that doesn't belong to a planet but to the galaxy itself. We must look to the most violent and precise objects in the universe, the pulsars. If we can learn to hear their rhythmic, metallic ticking, we might find a new way to navigate the dark. But as we are about to discover, even a cosmic lighthouse has its own terrifying secrets, and relying on the breath of dead stars to find your way home might be the most dangerous gamble humanity has ever taken. Because in space, even the lighthouses are moving, and the time they keep is not our own. When the radio falls silent and the stars begin to warp, the interstellar traveler is faced with a terrifying realization. You are an explorer in a world without a map. Every tool humanity spent 10,000 years perfecting, from the magnetized needle to the billion-dollar satellite, is a local toy, useless in the true deep dark. You are a mind trapped in a metal cylinder, drifting through a vacuum that has no floor, no north, and no memory of where you came from. But as the silence of Earth grows absolute, a new and stranger possibility emerges. What if the universe itself has a built-in GPS? What if the galaxy is filled with lighthouses that were shining long before humanity was born and will continue to pulse long after we are gone? This is the story of the pulsar, the cosmic lighthouse, and the desperate hope that the dying hearts of dead stars might be the only things capable of guiding us home. But as we are about to discover, even a galactic clock has its own dark secrets, and trusting the breath of a dead star is a gamble that could leave you lost in time as well as space. To understand why a pulsar might save us, we have to look at the most violent and extreme objects in the known universe. When a massive star dies, it doesn't always vanish into a black hole. Sometimes it collapses into a neutron star, an object so dense that a single teaspoon of its material would weigh as much as Mount Everest. This star, once 1,000,000 miles wide, is crushed down into a sphere no larger than a city, and as it collapses, it begins to spin. Because of the conservation of angular momentum, these tiny, dense hearts spin with a speed and precision that is almost impossible to grasp. They rotate hundreds of times every single second, and as they spin, they emit beams of intense radiation from their magnetic poles. Like a lighthouse on a rocky shore, these beams sweep across space with a rhythmic, mechanical perfection. When these beams cross the Earth, we see them as pulsars, flickering points of light that tick with the regularity of an atomic clock. For decades, astronomers have used these cosmic pulses to study the gravity of the universe. But for a starship navigator, a pulsar is something much more valuable than a scientific curiosity. It is a beacon, because each pulsar has a unique pulse signature, a specific rotation speed and a specific tick. They act as unique landmarks in the galaxy. If you can detect the signals from 4 different pulsars, you can use a process called time difference of arrival to triangulate your position in 3-dimensional space. It is exactly how GPS works on Earth, except instead of satellites orbiting our planet, your beacons are the collapsed remains of ancient suns scattered across thousands of light years. In the deep dark, where there is no north and no sun, the rhythmic ticking of a pulsar is the only heartbeat you have left to follow. The hope of pulsar navigation is not just a theoretical dream. In 2017, NASA conducted an extraordinary experiment aboard the International Space Station called Sextant. They used an instrument the size of a washing machine to detect X-ray pulses from several millisecond pulsars. For 2 days, the ISS ignored its GPS satellites and its ground-based tracking. It relied entirely on the light from dead stars to figure out where it was, and it worked. The system was able to calculate the station's position to within a few kilometers of its true orbit. It was a genuine miracle of engineering, the first time a human machine had ever navigated using the map of the galaxy itself. For a moment, it seemed that the problem of being lost in space had finally been solved. We had found the cosmic lighthouses. We had a way home. But here is where the unexpected twist begins, the moment the save turns into a strap. On the International Space Station, pulsar navigation is easy because the station is moving relatively slowly, and it is close to a known starting point. But on an interstellar starship, you're traveling at tens of thousands of kilometers per second. This speed introduces a phenomenon that begins to dismantle the pulsar's precision, relativity. As your ship accelerates, the tick of the pulsar begins to distort. Because you are moving toward or away from the beacon at a significant fraction of the speed of light, the timing of the pulses stretches or compresses. This is the Doppler effect, but on a cosmic scale. If your ship's computer miscalculates your velocity by even a fraction of a percent, the pulsar's map becomes a hallucination. You are trying to use a clock whose time is changing based on how fast you are running toward it. This leads to the total destruction of our assumption that the pulsar is an eternal landmark. We think of pulsars as fixed because they are so far away. But as we discussed with the stars, everything in the universe is moving. The pulsars themselves are hurtling through the galaxy on their own chaotic trajectories. This means the galactic GPS is not a fixed grid, it is a moving one. To navigate, you don't just need to know the pulsar's tick. You need to know exactly where the pulsar is at every second of your 50-year voyage. If a pulsar's position drifts, or if its magnetic field undergoes a sudden glitch, a rapid, unpredictable shift in its rotation speed, your navigational anchor is gone. You are tied to a lighthouse that is itself drifting in the storm. Think about the psychological reality of pulsar dependence. You are a crew member in year 70. The voice of Earth is a 40-year-old memory. The sun is just another star. Your entire survival depends on the ability of an X-ray sensor to pick out the faint, rhythmic ticking of a neutron star 10,000 light-years away. You sit in the quiet of the bridge, listening to the digital ping of the pulsar, realizing that your only connection to reality is the heartbeat of a corpse. If the sensor fails, or if the radiation of deep space corrupts the ship's pulsar catalog, you are truly permanently blind. You aren't just lost in space, you are lost in a universe that has no other landmarks to offer. The pulsar is not a savior. It is a thin, fragile thread that is all that stands between you and the infinite dark. But there is a deeper, more unsettling problem hiding inside the pulsar's tick. Even if your sensors are perfect and your velocity is accounted for, you are faced with the age of the signal. The light you are receiving from a pulsar today left that dead star thousands of years ago. You are navigating based on the now of a star that might have already vanished, exploded, or changed its rotation. You are trying to build a map of the present using the echoes of the ancient past. And as you travel faster and further, you begin to realize that the universe is not just lying to you about where things are, it is lying to you about when they are. This is where the dream of pulsar navigation hits the final wall. You realize that you aren't just trying to find a place, you are trying to find a moment. And in the deep dark, time doesn't behave the way it does on Earth. As we move into the next section, we are going to discover the most terrifying secret of the interstellar voyage, the moment the universe stops being a map and starts being a prison of time. We are going to look at why, even with a perfect GPS, you might arrive at a home that has already moved on, not just in space, but in centuries. You aren't just losing your way, you are losing your now. And this leads us to the relativity trap. If the pulsars are the clocks of the galaxy, then what happens when the very act of reaching for them causes time itself to break? We are about to enter a realm where once you leave, you can never go back, not because you can't find the road, but because by the time you do, the road no longer exists. The universe isn't just vast, it is a time machine that only moves in one direction, and it's about to show you why home was never a place you could return to. We have spent our entire lives believing in the absolute authority of the clock. On Earth, time is the one thing we all agree on. It is the rhythmic, unchanging beat of our existence. Whether you are in London, Tokyo, or New York, a second is a second. We assume that if we look at our watches and see that it is 12 o'clock, then it is 12 o'clock for everyone everywhere at exactly the same moment. This concept is called simultaneity, the idea that now is a universal truth. It is the foundation of our history, our navigation, and our sanity. But as a starship accelerates into the deep dark, reaching for the staggering speeds required to cross the light years, this foundation doesn't just crack, it vanishes. You are about to enter a realm where the universe begins to lie to you about the very nature of time itself. You are going to discover that in the interstellar void, now is a ghost, and the faster you travel to find your way home, the further that home drifts into a future you can never truly be part of. This is the ultimate trap of the cosmos. You aren't just lost in space, you are lost in time. To understand why the universe lies, we have to look at Einstein's most unsettling revelation, special relativity. Einstein discovered that time is not a fixed background, but a flexible fabric that is woven together with space. And most importantly, time is relative to speed. The faster you move through space, the slower you move through time. On Earth, we never notice this because our fastest planes and rockets are moving at a microscopic fraction of the speed of light. To us, the clock is absolute. But for a starship traveling at 10, 20, or 50% of the speed of light, time dilation is no longer a mathematical curiosity. It is a physical, life-altering reality. It is a slow, silent stretching of existence that ensures that even if you have a perfect map, the world you are mapping is aging faster than you are. Imagine you are a pilot on an interstellar mission to Alpha Centauri. You leave behind a twin brother on Earth. You are both 30 years old. Your ship accelerates to 90% of the speed of light. To you inside the ship, everything feels normal. You eat, you sleep, you breathe at the same pace you always have. Your ship's atomic clock ticks with perfect regularity. But the universe is performing a cruel trick on your biology. Because you are moving so fast, your now has decoupled from the now of Earth. For every year that passes for you on the ship, more than 2 years pass for your brother back home. By the time you reach your destination and turn around to look back, you are 34 years old, but your brother is nearly 40. And when you finally return to the solar system after what felt like an 8-year voyage, you step out of the ship to find a world that has aged nearly 20 years. Your friends are gone, your brother is an old man, The home you were navigating toward has outrun you. This is the relativity trap. In deep space, navigation is no longer just a three-dimensional problem of X, Y, and Z coordinates. It is a four-dimensional nightmare. To find your way back, you don't just need to know where Earth is, you need to know when Earth is. If your ship's computer tells you that Earth is at a certain point in its orbit, that information is based on the ship's time. But Earth is existing in a different time stream. You are like a man trying to catch a train, but the train is moving in a different dimension of time. You arrive at the station, and the train hasn't just left, it left 20 years ago. You are a ghost from the past trying to inhabit a future that was never meant for you. The universe isn't just keeping you apart by distance. It is using the very laws of physics to ensure that you can never truly return to the moment you left. Think about the psychological toll of this temporal vertigo. On Earth, we have a sense of continuity. We know that as we travel, the world we left behind is progressing at the same rate. We feel connected to the current event of humanity. But in deep space, you're severed from the human timeline. You might receive a radio transmission from Earth, a video of your child's first steps. But because of light delay and time dilation, by the time you watch that video, your child might already be an adult. You are looking at a now that is already ancient history. You are mourning people who haven't died yet in your timeline, and you are celebrating birthdays for children who are already old. The ship becomes a time capsule in the most literal sense. You are preserved in a bubble of slow time while the rest of the universe screams ahead of you. You lose the ability to feel current. You are a relic of a previous era, drifting through a void that has moved on without you. But the lie goes deeper. Einstein also destroyed the idea of absolute simultaneity. He proved that there is no such thing as a universal right now. If you and an observer on Earth both look at a distant supernova, you will not agree on when it happened. Your speed and your position change the very order of events. In deep space, the sequence of the universe is a matter of perspective. This is the final blow to navigation. We assume that a map is a static thing, a snapshot of reality, but a map requires a now. If you can't agree on what time it is, you can't agree on where anything is. You are trying to find your way home in a universe where the landmarks are not only moving, but are existing in different versions of the present. You are navigating a house where every room has its own clock, and all of them are running at different speeds. This leads to the total destruction of our assumption that finding home is even possible. Most people believe that if we just build a fast enough ship, we can conquer the stars. But the faster you go, the more the universe lies to you. If you could travel at 99% of the speed of light, you could reach the center of the galaxy in a single human lifetime. But when you returned, Earth would be 50,000 years in the future. The human species might be extinct. The very planet might be unrecognizable. The faster you reach for the stars, the more you erase the world you left behind. Interstellar travel is a trade. You get the stars, but you lose the Earth. You get the distance, but you give up the now. We tell ourselves that we are explorers, but to explore, you must be part of a story. And a story requires a shared timeline. Interstellar space is the end of the shared story. It is a place where every traveler is their own timeline, their own history, and their own lonely version of the present. You look out the window at the Earth, and you realize that you aren't looking at a planet. You are looking at a ghost of a past that you have already outlived. You are a man standing on the edge of a cliff, watching a ship sail away. Realize that the ship is your own life, and there is no way to jump back on board. The universe isn't just vast. It is a time machine that only moves in one direction. And as you push deeper into the dark, the now of home becomes a flickering candle that eventually goes out. You are left with the realization that even with a perfect pulsar GPS and a perfect starship, you can never truly find your way back. Not because the road is gone, but because the you who left is a different person than the you who returns, and the Earth you return to is a stranger. You are lost in the machinery of time, and the universe is the only one who knows the truth. But as the now of home vanishes and the stars begin to lie, a final, desperate question emerges. If the universe is a time machine and the landmarks are shifting, and we are lost in the fabric of relativity. Then how do we even begin to find the Earth again? How do we find one tiny blue grain of sand in a desert of 100 billion stars, when even the desert itself is a hall of mirrors? In the next section, we are going to look at the search for the needle, the terrifying reality of trying to relocate a single planet in a volume of space so vast that even a perfect calculation might not be enough. We are going to look at why finding Earth again might be the hardest thing humanity has ever attempted, because in space, the needle isn't just hidden, it's invisible. We have reached the point in our journey where the abstract laws of physics collide with the cold, hard reality of the search. We have seen how the universe lies to us about time, how the stars distort our vision, and how the very concept of a fixed home is a biological illusion. But now we must face the final, most practical nightmare of the interstellar navigator. Suppose you have survived the centuries. Suppose you have managed to keep your ship functional and your crew sane. Suppose you have reached the nearest star and decided, for whatever reason, that it is time to return. You point your ship toward the coordinates where your ancient charts say the sun should be. You fire your engines. You begin the long, agonizing slide back through the dark. But as you look out into the abyss, you realize that you aren't just looking for a star. You are looking for a grain of sand in a desert that has no edges. You are looking for a single, pale blue light in a sea of 100 billion suns. And this is the moment where the mathematics of the void finally shows its teeth. This is the search for the needle, and in deep space, the needle is not just hidden, it is functionally invisible. To understand the impossibility of the search, we have to look at the geometry of error. On Earth, we think of a 1-degree error as something small. If you're building a house and your wall is off by 1 degree, you might not even notice. But in the interstellar void, 1 degree is a death sentence. To understand why, imagine a cone stretching out from your ship. If you are 4 light years away from Earth and your navigation is off by just 1 single degree, that error expands into a gap of over 400 billion kilometers by the time you reach the solar system. That is a distance wider than our entire planetary neighborhood. You wouldn't just miss the Earth, you would miss the sun. You would sail past our entire world in the dark, never even knowing you were close. To find home, your precision must be measured not in degrees, but in arcseconds. Divisions of a degree so small they are like trying to hit a penny with a laser from 10 miles away. 1 microscopic vibration in your ship's hull, 1 tiny rounding error in your computer's trajectory, and you are no longer a traveler. You are a ghost passing through a graveyard. But let's assume your math is perfect. Let's assume you've managed to aim your ship with godlike precision. You are now approaching the region of space where the sun should be. You activate your long-range sensors. You look for that familiar yellow spark, but this is where the luminosity trap begins. Our sun is a medium-sized star, a yellow dwarf that seems bright to us only because we are standing right next to it. But on the scale of the galaxy, the sun is unremarkable. It is a dim, flickering candle in a room filled with brilliant stadium floodlights. From a distance of just a few light years, the sun is indistinguishable from millions of other stars. It doesn't have a special color. It doesn't have a unique pulse. It is just another point of light in a crowded sky. To find the Earth, you first have to find the sun, but to find the sun, you have to filter through 100 billion false positives. You are a man in a dark stadium, trying to find one specific flashlight among thousands, while the flashlights themselves are constantly moving. And even if you find the sun, the real nightmare is just beginning. You are looking for Earth. But from the perspective of a starship approaching from deep space, the Earth does not exist as a planet. It exists only as a transit. To your sensors, the Earth is a tiny, microscopic speck that is billions of times dimmer than the sun it orbits. This is the glare problem. Imagine standing 10 miles away from a massive, brilliant lighthouse. Now, imagine a tiny firefly flying just a few inches away from that lighthouse's lens. From your distance, the firefly is completely drowned out by the light. You cannot see the firefly. You can only hope to see the moment it passes in front of the light, causing a microscopic dip in the lighthouse's brightness. This is how we find planets today, and it is how a starship would have to find Earth. You aren't looking for a blue marble, you are looking for a shadow. You are waiting for a planet to cross its star so you can prove it's even there. But Earth only transits the Sun once every 365 days. If you miss that window, or if your ship is not perfectly aligned with the Earth's orbital plane, the planet remains invisible. You could be just a few billion kilometers away, and the Earth would be hidden in the glare of the Sun, a silent, mocking ghost that refuses to be found. Think about the search radius of this desperation. If your initial navigation was off by even a fraction of a percent, the volume of space you have to search is staggering. It is a cube of blackness billions of kilometers wide. You have to point your telescopes at every star that looks even remotely like the Sun. You have to wait for transits. You have to analyze the wobble of those stars to see if they have planets. And you have to do all of this while your ship is still moving, while your life support is still failing, and while your crew is still aging. You are a sailor lost in the middle of the Pacific Ocean, with no compass and no radio, trying to find a single, specific pebble on a beach 1,000 miles away. Every star you investigate and find empty is a month of wasted fuel. Every false positive is a year of stolen time. The search is not a scientific process. It is a grinding, agonizing process of elimination that eats your resources until there is nothing left. The psychological toll of this search is the ultimate retention killer of the mission. For centuries, the crew has been sustained by the promise of the return. They have lived for the moment they would see the Earth again, but now they are near home, yet they are more lost than ever. They can see the Sun, but they can't find the planet. They are in the neighborhood, but they can't find the house. This creates a specific kind of madness, a proximity despair. You are so close that you can almost feel the gravity of home, but the universe refuses to show you the door. You are trapped in an orbital limbo, scanning the dark, watching the fuel gauges drop, realizing that you might die in the very system you were trying to save. You are like a man who has reached his front door, but the key has been erased, the lock has been moved, and the house has become a transparent ghost. But let's look deeper into the albedo paradox. We call Earth the blue marble because it reflects sunlight, but Earth's reflectivity, its albedo, is incredibly low. Most of the light that hits our planet is absorbed by the oceans or the soil. Only a tiny fraction is reflected back into space. From a few billion kilometers away, Earth is not a brilliant blue beacon. It is a dim, grayish-blue speck that is barely brighter than the background noise of the universe. To find it, your sensors have to be perfectly calibrated to detect the specific chemical signature of our atmosphere, the presence of oxygen, nitrogen, and methane. But those signatures are faint. They are easily distorted by the radiation of the Sun or the dust of the solar system. You are trying to smell a single rose in the middle of a burning forest. The universe isn't just hiding the Earth, it is actively trying to camouflage it. This leads us to the technological desperation. As the search continues and the failures mount, the crew is forced to try more and more extreme methods. They might begin to broadcast massive radio pings, hoping for an echo from Earth's moon or its satellites, but those pings take hours to return. They might try to use the Sun itself as a gravitational lens, a trick of physics that allows a star's gravity to magnify the light of things behind it. But to use a lens, you have to be in the perfect position, a sweet spot billions of kilometers away. Every maneuver to find that spot consumes the very energy you need to survive. You are bartering your future for a chance to see your past. You are burning your furniture to keep the house warm, knowing that eventually there will be nothing left to burn. Consider the false hope of the gas giants. As you search the Sun's neighborhood, your sensors will almost certainly find Jupiter and Saturn first. They are massive, they are bright, they are easy to find. For a moment, the crew celebrates. They have found a planet, they are home. But as the ship approaches, they realize the horror. It is a gas giant, a world of crushing pressure and poisonous clouds. It is not home. It is just another dead end. The solar system is a hall of mirrors, filled with Earth-likes and near misses that exist only to waste your time and your spirit. Each gas giant you find is a psychological blow that erodes the crew's commitment to the search. They begin to ask, what if the Earth is gone? What if the charts were wrong? What if we are looking for a world that has already been destroyed? The search for the needle is the final proof that we are not meant for the stars. We are biologically and technologically tuned to a very specific local reality. We can find our way around a planet, but we cannot find our way around a galaxy. The sheer scale of the search volume is a physical barrier that no amount of AI or laser optics can truly overcome. We are trying to navigate a universe that was never designed for us to leave, and it certainly wasn't designed for us to return. We are like a virus that has escaped its host cell, only to realize that the body it is in is an infinite void with no other hosts to cling to. And as the search drags on, a final chilling realization sets in. Even if you find the Earth, even if your sensors finally lock onto that tiny blue-gray speck, you might not be able to reach it, because finding it is only the first step. To return, you have to match its velocity, you have to enter its orbit, you have to slow down from 20% of the speed of light to just a few kilometers per second. And as we will discover in the next section, the technology required to stop is even more impossible than the technology required to find. You might find yourself watching the Earth fly past you at 3,000 kilometers per second, a beautiful, unreachable dream that you can only see for a single, heartbreaking afternoon before you are carried back out into the eternal dark. But surely there is a better way. Surely the future will bring us a technology that makes this search easy. Laser beacons, quantum sensors, or AI navigators that can scan the entire galaxy in a heartbeat. We call this future hope, and in the next section, we are going to look at the cutting edge of human imagination. We are going to see why, despite all our genius, even the most advanced technology of the future cannot solve the fundamental information gap of the universe. We are going to look at why the weight calculation was right all along, and why the best way to find your way home might be to never leave it in the first place. We are a species defined by our refusal to accept the word impossible. Every time we have hit a wall in our history, we have built a ladder. When the oceans were too wide, we built ships. When the sky was too high, we built wings. When the moon was too far, we built rockets. Our entire narrative as a civilization is one of technical triumph. The belief that any problem, no matter how vast, is simply an engineering challenge waiting for a clever enough solution. And so, as we look at the terrifying obstacles of interstellar navigation, our natural instinct is to look to the future. We tell ourselves that the problems of the digital rot, the thermal paradox, and the moving target of Earth are only problems because we are still primitive. We imagine that in 100 years, or 500, we will have the tools to make the universe feel small again. We dream of laser beacons, quantum sensors, and godlike AI navigators that can stitch the stars back into a map we can understand. But as we are about to discover, even the most advanced technology of the future must eventually bow to the same unyielding laws of physics. We are trying to build a better ladder, but the wall we are facing is made of the very fabric of space and time. The first and most promising dream of the future is the interstellar lighthouse, the laser beacon. The idea is elegant. If radio waves are too slow and too weak, we use light. We build massive, high-powered laser arrays on the moon or in orbit around the sun. These lasers would point toward our outgoing starships, sending a perfectly straight, tightly focused beam of information through the dark. This beam would be a literal lifeline, a physical connection to home that never moves. By measuring the timing and frequency of the laser, a starship could calculate its distance and velocity with a precision that radio could never achieve. It would be a highway of light, a path that cuts through the uncertainty of the void. In this vision, getting lost is impossible because the light of home is always behind you, a brilliant, unwavering needle pointing the way back. But the laser dream collapses under the weight of the aiming problem. To hit a starship 4 light years away with a laser beam, you have to aim with a precision that is almost incomprehensible. You aren't just aiming at a ship, you are aiming at where the ship will be years into the future. If the ship makes a tiny course correction, or if its own thrusters vibrate by a fraction of a millimeter, it moves out of the beam. And because of the light delay, Earth won't know the ship has moved until years later. The highway of light is actually a flickering, unstable thread that can snap at any moment. And even if you stay in the beam, you face the divergence paradox. No matter how tightly you focus a laser, it eventually spreads out. By the time a laser from Earth reaches Alpha Centauri, it has expanded from a narrow beam into a circle of light millions of kilometers wide. The signal becomes a whisper. The precision becomes a blur. We are trying to use a laser pointer to hit a grain of sand across an ocean, while the ocean itself is constantly moving. So we look to the next frontier, quantum navigation. This is the holy grail of future tech. Sensors that use the strange, non-local laws of quantum mechanics to measure motion with zero drift. We imagine a quantum gyroscope that doesn't rely on spinning wheels or vibrating crystals, but on the interference patterns of atoms. Such a device would be thousands of times more accurate than anything we have today. It would be a perfect memory, a machine that records every microscopic movement of the ship with absolute fidelity forever. With a quantum sensor, dead reckoning would no longer be a trap. You would always know exactly how many steps you've taken, and your map would never lose its sharpness. You would be the master of your own trajectory, a traveler who can never be lost because your internal sense of direction is as absolute as the universe itself. But even a perfect memory cannot save you from an imperfect reality. A quantum sensor can tell you exactly where you have moved, but it cannot tell you where your destination has moved. As we've seen, the Earth, the Sun, and the stars are all in a state of chaotic nested motion. Your quantum sensor can give you a perfect record of your own path, but it can't account for the great attractor pulling your galaxy or the expansion of the space in between. You have a perfect map of your own movements, but you're still walking on a carpet that is being dragged across a room you can't see. And then there is the problem of quantum decoherence. In the high radiation environment of deep space, even a quantum sensor is under attack. A single cosmic ray striking the sensor's atomic chamber can collapse the delicate quantum state, introducing a tiny, irreversible error. Even the most perfect machine is eventually dismantled by the entropy of the void. Finally, we look to the ultimate navigator, the AI god. We imagine a superintelligence that can process every star in the Gaia map, the massive stellar catalog produced by the European Space Agency. This AI would monitor billions of stars simultaneously, accounting for every proper motion, every parallax shift, and every gravitational lens effect in real time. It would be a mind that never sleeps, a mind that can see the 3D structure of the galaxy as clearly as we see the streets of our hometown. This AI would be able to recalibrate the ship's position every second, using the entire universe as its GPS. With an AI god at the helm, the stars would no longer be strangers. They would be the familiar nodes of a vast digital network. But an AI is only as good as the eyes it sees through. As we discussed in the digital rot, a century of radiation exposure degrades every camera lens, every sensor plate, and every silicon chip. The AI might be a genius, but if its eyes are clouded by pixels and sensor noise, it is a genius in a dark room. It begins to make inference errors. It starts to guess. And in the interstellar void, a guess is just a slow-motion catastrophe. Furthermore, an AI god introduces a black box crisis of its own. If the AI tells the crew that they are on course, but the stars look wrong to the human eye, who do they trust? We are handing over the steering wheel of our species to a machine whose logic we can no longer follow. We are passengers on a bus where the driver is a god, and we have no way to know if the god is still sane. This brings us to the ultimate realization of future technology, the speed limit of information. No matter how advanced our sensors become, no matter how powerful our lasers grow, they all must travel at the speed of light. This is not a technical problem, it is a structural one. The universe is built with a refresh rate. Information from the edge of the solar system is always hours old. information from the nearest star is always years old. This means that we are always navigating based on a snapshot of the past. Future technology can give us more detail in that snapshot, but it cannot make the snapshot current. We are trying to navigate a real-time world using a delayed time map. Every interstellar GPS we can conceive is fundamentally, physically out of sync with reality. We tell ourselves that the future will solve it, but this is often just a way to avoid the humbling truth of our own limitations. We are trying to conquer an infinite abyss with tools that are fundamentally finite. Laser beacons will spread and fade. Quantum sensors will decohere and drift. AI gods will suffer from digital dementia. Future technology is not a magic wand, it is just a better shovel. It allows us to dig deeper into the dark, but it doesn't change the nature of the whole. We are a species that lives for 70 years, trying to build machines that last for 700, to cross distances that take 7,000. The math of the universe is simply not on our side. This leads us to the final, most emotional rung on the ladder. If the technology of the future cannot save us, and the maps of the past are lying to us, then what happens to the people who actually make the journey? What happens to the star children born in Century 3 of a voyage to TRAPPIST-1? To them, Earth isn't a place to find, it's a myth to be debated. And as we move into the final section of our journey, we are going to look at the end of home. We are going to discover why the greatest challenge of interstellar travel was never about reaching another star. It was about accepting that once you leave, you can never go back, not because you can't find the road, but because the person who started the journey died a long time ago. The home we are looking for is not a coordinate in space, it is a moment in time. And as the starship pushes further into the dark, that moment isn't just getting further away, it is becoming a different universe entirely. We are entering the era of the myth, where the starship is no longer a vehicle, but the only world that exists. And for the people inside it, the word back is no longer a direction. It is a fairy tale. We have reached the end of the map. We have seen the digital brains of our ships succumb to dementia, the hulls of our vessels turn into material graves, and the very stars themselves warp into strangers that no longer recognize us. We have dismantled every tool, every theory, and every hope of a simple return. But as the long, 2-hour journey of this exploration comes to a close, we must confront a truth that is far more unsettling than any engineering failure or relativistic trap. It is a truth that doesn't live in the circuits of a computer or the equations of a physicist, but in the fragile, haunted corridors of the human spirit. We have spent Sadian wondering how to find our way back to Earth, but we never stopped to ask if the Earth we remember would even be there to find. This is the final realization, that in the deep dark of interstellar space, home was never a coordinate. It was never a latitude or a longitude. It was a moment in time, a specific flickering candle in the history of the universe, and the second we stepped out the front door, we blew that candle out forever. To understand the emotional finality of the void, we have to look at the life of the star children, the generations born in the middle of a 400-year voyage. Imagine a girl born in year 150 of a mission to TRAPPIST-1. She has never seen a horizon that didn't curve upward into a metal ceiling. She has never felt the weight of a world that wasn't created by a rotating cylinder. To her, rain is a maintenance cycle in the agricultural bay. Wind is the hum of a ventilation fan. She lives in a world of stale, recycled air and flickering LED panels, and yet she is told every day that she is a traveler. She is told that she is heading toward a new home, but she has no memory of the old home. To her, Earth is not a planet, it is a high-definition myth. It is a collection of files in a digital archive, images of blue oceans and green forests that look as fantastical to her as a dragon or a ghost. She is part of a sunset civilization, living in the service of a goal she didn't choose, maintaining a machine that is older than her entire family tree. This is where the social rot of the voyage becomes absolute. On Earth, we are grounded by our history. We have ruins to look at, ancestors to bury, and a planet that remembers us. But on a starship, history is just data, and data can be deleted, corrupted, or ignored. By the third or fourth generation, the purpose of the mission begins to evaporate. The crew realizes that they are not explorers, they are the maintenance generation. They are the biological grease in the gears of a dream that died with their great-grandparents. The psychological distance from Earth grows faster than the physical distance. The language begins to drift, the values begin to shift, and eventually the Blue Mother is forgotten. Earth becomes a religious abstraction, a paradise that was lost not because of sin, but because of a trajectory. The ship is no longer a vehicle, it is the only world that is real, and in this closed-loop existence, the word back loses its meaning. You cannot go back to a fairy tale. But suppose, against all odds, the ship survives. Suppose the 20th generation decides to turn around and retrace the path of their ancestors. They fight the search for the needle, they calculate the moving targets, and they successfully navigate the Hall of Mirrors that is the interstellar void. After 500 years, they arrive at the solar system. They look out the observation port, expecting to see the world of the archives, but they are faced with the ultimate temporal horror. Because of the light delay and the time dilation we explored, the Earth they have returned to is not the Earth they left. 5 centuries of history have passed. The civilization that launched the ship is gone. The language they speak on the bridge is a dead tongue. The technology they carry is a museum piece. They step out of their ship like ghosts from the past, arriving in a future that has no place for them. Their families are dust. Their culture is a footnote. They have found the coordinates, but they have lost the home. They realize, with a crushing, existential weight, that they are the only people in the entire universe who remember the world they were trying to save. This is the final verdict of our journey. The greatest challenge of interstellar travel was never about rockets, or fuel, or even the digital rot of the ship's brain. The greatest challenge was always the weight calculation of the human heart. We are a species that lives and dies in the blink of a cosmic eye. We are biologically tuned to the scale of decades, yet we are trying to navigate a universe that operates on the scale of millennia. When we launch a starship, we are not sending a message to another star. We are sending a divorce settlement to our own planet. We are cutting ourselves off from the shared timeline of our species. The moment the engines fire and the sun begins to shrink, the umbilical cord is not just stretched, it is severed. Interstellar travel is a one-way door, and once you step through it, the universe ensures that you can never truly walk back in. We tell ourselves that we are conquerors of the dark, but we are actually just castaways on a beautiful blue island. We look at the stars and see destinations, but we should be looking at them as warnings. They are reminders of the distances that keep us apart and the time that erases who we are. Every light year we travel is a year stolen from our identity. Every star we reach is an Earth we lose. We are trying to find our way home in a universe that is designed to make us forget where that home was. As you look up at the night sky tonight, I want you to think about Voyager 1. It is 24 billion kilometers away, its power fading, its sensors dimming, its voice becoming a whisper. It is the furthest we have ever gone, and yet it hasn't even left our own front yard. It is a monument to our curiosity, but it is also a monument to our isolation. It is carrying our voices, our music, and our images into a silence that will last for 1 trillion years. Voyager is not lost. It knows exactly where it is, but it also knows that it can never come back. It has accepted the final verdict of the stars. The dream of the starship is a beautiful delusion. It is the belief that we can outrun time and outsmart entropy. But the universe is a patient predator, and it knows that eventually every machine breaks and every memory fades. We may one day reach another star. We may settle a new world under a red sun, but we will not be the humans who left. We will be something new, a species of the void, a civilization of the ship, a people without a past. The home we are looking for will be a myth told by firelight in the corridors of a dying machine, a story of a blue planet where water fell from the sky and the ground stayed still. The greatest challenge of interstellar travel may never be reaching another star. It may be accepting that once you leave, there is no way home, because home was never a place you could point to on a map. Home was the people you left behind, the time you can never reclaim, and the sun you will never see again. We are the infants in the dark, reaching for the lights in the ceiling, never realizing that the room we are in is the only one we will ever truly know. Thank you for joining me on this 2-hour journey into the deepest mysteries of the void. If this exploration has changed the way you look at the stars, take a moment to like the video and subscribe to the channel. It helps us keep making these deep dives into the heart of the cosmos. And the next time you look at the night sky, remember, the stars aren't just points of light. They are the boundaries of our dreams and the guardians of a silence that will outlast us all. Good night, and may you always find your way, even when there is no road back.